Hello everyone, my name is Wenxuan and I'm from Group21. Our topic is going to be Smart Commercial, Traffic Congestion and Emission Fleet Management System. So our team consists of An Liang, Ling Pam Chong, Ming Wenxuan, and Yak Kai Jin. So firstly, it's going to be the introduction to our system. So this system is built to reduce traffic congestion and emission, mainly by using route optimization. This can be beneficial to a group of people like delivery companies, individual drivers, citizens, and etc. So we have three formal statements for our system. So we want to solve the inefficient route planning of logistics company, the lack of vehicle maintenance monitoring, and also the limited visibility and manipulation into fleet activities. So the objective for our system is going to be firstly, real-time visibility. We want to reduce the fuel consumption and improve delivery efficiency. Secondly, it's going to be implementing a predictive maintenance system by scheduling and reduce unplanned vehicle downtime and also to decrease the repair costs. Thirdly, is going to be enhanced visibility into fleet activities. We want to increase on-time deliveries, ensure compliance with safety regulations, and also reduce operational efficiency. So this is the architecture diagram. So we will explain it in the demo part. Hello everyone, my name is Wenxuan, and now I will be doing a demo for IoT Core. So first, you will need to go to All Device here and then go to Things. Okay. Then we create a thing. So we create a single thing. So create a single thing, we give it a name and then just next. And then we download the device certificate. So we give it a name here, we put truck one. Then next. So the default settings here. So we will click on auto generate a new certificate. Next. And then we will attach this policy here. So we attach the truck policy. Then we create the thing. So we will have to download all the certificate here. Okay. So next, we need to go to the user manual and to download the AWS IoT SDK. So we have to go into this link here to find for the SDK. So we will need to download the device class here that's shown here. This is the device class. So we have to download it. And then we also have to save the certificate into the files as well as where the SDK is stored. So this is the Visual Studio Code. We will use this to configure the JS script here. So this is the thing that I created. So you will need to paste your private key here, your certificate. So it's going to be the name and also Amazon root ca1.pem. So this host here is going to be the API key that you can find from the settings here. So you can go to security, or you can go to settings. And then you can just copy this device endpoint here and paste it there. So to see if it works, you can use MQTT test client. So you can subscribe to the topic. So we have truck 1 as the topic here. So we will subscribe to it and then we will start to receive message. So we can go back to here and then just use not truck 1. And then it will start to run the script and then it will attempt to make a new MQTT connection. And then, okay, you see, we have the connection here. So this is the JSON string. So we will receive it here. And then we can also publish a message to receive in here also. See, hello from AWS IoT Core. Okay, so that is for IoT Core. Next, we'll move on to the function lambda here. So we can create a function. So we use auto from scratch, give it a name, and then we will choose Python for this. And then you just create the function. And then I already have a function created here. So it's called put DynamoDB. It basically get the S3, the JSON file in S3, and then put it into the DynamoDB, and also trigger an SNS service. So this is going to be the code here. So give it time. So we'll be going to use Python for this, and we'll extract from the bucket when a new item is created in a bucket. And then it will take it out and then put it into DynamoDB using this table. And then we are using mileage here. If a certain mileage is reached, the condition reached, it will send an email notification. Service is needed, mileage is blah blah blah. Please submit your vehicle truck ID. So next we'll move on to subscribe to an SNS. So we will go to the SNS and make it topics here. So we create a topic, and then it's going to be a standard topic, give it a name, display name, and then we will do a create topic here. And then after we create topic, you have to make a subscription. So you have to create a subscription. So you will give it just now the topic ARN. There will be an ARN for the topic that you just created. And then you can select protocol to use SMS or to use email. And then you just create subscription. Then you will need to go to your email. You will need to go to your email here. So you will have something like this. Oh, sorry. You will have a subscription confirmation here. So you just click on confirm subscription. And then that's all for this NSS. So next we'll create a S3 bucket. So you can create a bucket here. And then just for general purpose, give it a bucket name and then just deselect this all and then select this on language. Then we'll just create a bucket. That is for the S3 bucket. For DynamoDB, you just create a table, give the table name, enter the primary key here. So the partition key is simply be a primary key, and just keep all the default settings, and then we create a table. So when a file, right, is when this device is triggered, it will send a message to IoT core, and from IoT core, it will be using the rule here. So that's going to be a message routing, and then there's rules. So in this rules, it will send it. It will use this rule to send the topic, select all from struct1, and send it to the S3 bucket. So the S3 bucket here. So it will store in the S3 bucket in a JSON file like this. So in it will be like JSON file. Then it will trigger the DynamoDB here to trigger from here and then go to here to into DynamoDB. And if the data mileage is more than 10,000, then it will send the SNS. So in here we have a example of the message that is sent. Service is needed. Mileage is 20,000. Please serve it equals struct 20. So that's all the demo for my part here. Thank you.
Good day, sir. My name is Ang Liang, student ID 2100552. So now I'm going to explain to you about my part. My part consists of three things: Amazon Antenna, Amazon QuickSign, and Amazon DynamoDB. So Antenna is basically a connection for the DynamoDB and QuickSign, these two to connect, and that's why we use Antenna. And then QuickSign is to create dashboards, dashboard for people to see clearly. And then DynamoDB is to save data, as it says in the name. Okay, now I'm going to show you how it's done. So first we will go to DynamoDB. I'm just going to show you how it's done. Go to tables. And then this is my data set. Okay. I have only created 20 because it is sufficient for our part. And then after you have created this, after you have created your DB, you go to antenna. Under the antenna section, you have to see, you have to go to your data source. Okay, this is where you create your data source. And one thing to note that when you are creating your data source, you have to create a lambda function. And this lambda function for my it's just a function for you to connect these two together. And in order to finish this setup, you have to create one for this antenna. And then take note that there's this spill bucket where you have to create in the S3. And for my S3, you will be seeing this truck info and also truck spill bucket. Okay, once you have that, you have created your lambda, and then you put it in and press next to follow or to finish up all the things. And under the step 3, just review and create. So once you have created your Amazon antenna, you go to QuickSign real quick. Okay, go to QuickSign, and I'm just show you how it's done. Go to dataset, create new data, press this, and then this is the one that I have created. Drag info, yes. Okay, then edit preview. You will see this, you'll be seeing this, and also you have to change your data type under here. You can change to integer, and for the date, change to date. After you have done all of this, you will see this. Yes, you'll see this. You'll be given like a few options for you to choose, and then I pick these three. Okay. One more thing to notice before you begin doing this quit sign, please go to manage quit sign and go to security permission to check that you have given access to these 5 services. Once you are done, then only you go to create your data sets. And that's all from my part. Thank you.
So I'll proceed the remaining part of this architecture diagram. Location updates from the connected vehicle, which is truck, are sent over using MQTT to this IoT core message broker to a specific topic. The IoT core rule picks up the topic and invokes a lambda function, which in turn sends the location updates to the location service tracker. The tracker saves the location with itself and generates a location update event. The event bridge catches the event and sends it to a lambda function. This lambda function is responsible for sending the message to the user through this API gateway of WebSockets. In order to send message over WebSocket to user, WebSocket connection IDs are needed. These IDs are stored in DynamoDB when user connects to API gateway over WebSockets. And this connector is used for user to invoke AWS service by creating an access management pool. Lastly, this S3 bucket is used to host a static website for receiving location updates through this API gateway and also simulating the movement of trucks. So let's open the AWS configuration. First one is the IoT core. Find the rules and create this rule and implement this SQL statement and also involve this necessary lambda function. Fleet location save. For location service, create a tracker, name it as fleet tracker, and enable these event bridge events. For event bridge, create a rules, name it as fleet location event rule, and involve this lambda function, fleet location send to client. In lambda, I have 4 functions. The first one is fleet location save, I just now mentioned. You can see the trigger IoT, and also this necessary source code, and also the necessary rows for it. For this one, also the same. You can see the triggers and also the rows for it, and also the necessary source code. For these 2 functions is for WebSocket connection. The first one is fleet save WebSocket connection ID for saving the connection ID. You can see the rows as well, the triggers API gateway, and also the code, which is connected to the DynamoDB. For this one is similar to previous one. Also has the necessary rows and also the triggers, and also the codes, which is similar. For API gateway, I've created 2 connections. The first one is connect. The second one is disconnect. Once you created, you need to deploy this API and select the stage and name it as production, and you'll see the result in the stages. And this URL eventually I will put in my index JavaScript for connection with this API gateway. In DemoDB, you can see my previous tested connection IDs. For Cognito, I've created an identity pool named as fleet identity pool, and also implement the necessary permissions like fleet Cognito IAM roles for it. So lastly, we open this S3 bucket. I created a bucket called it fleet tracking and uploaded these necessary files, and I have opened up this index HTML. Let's try it, and also the simulator HTML. So let's see the developer console. You see everything is good, but this one is just for extension problems, so don't mind it. Once I click this and send trucks location data every 2 seconds, it pops up the coordination of trucks for 1 to 4. I have 4 trucks in total for the sample. And just moving to index.html. Once you click this button, you'll see the trucks. Yeah. And let's look up the developer tools for this index.html. Yes, you receive these location updates of every trucks. And every trucks have the markers behind of it. That's all for this part.